A single subatomic particle hit Earth traveling so close to the speed of light that if a beam of light raced it across the entire universe, light would only win by less than a single centimeter. A single centimeter! It carried the impact force of a high-speed baseball, launched straight out of a dead zone in deep space, where literally nothing is supposed to exist. For over a century, Albert Einstein's special theory of relativity has held an iron grip on physics. It established a hard cosmic speed limit, 186,282 miles every single second. Light travels this fast because it has zero mass. Photons glide through space with zero resistance, 7.5 times around the Earth in a single heartbeat. But the second you add mass, even a single microscopic proton, the universe demands an infinite amount of energy to push it anywhere near that limit. To accelerate a single human to the speed of light, you would need more energy than exists in the entire observable universe. And yet, deep space keeps firing particles at us that shatter our understanding of reality. Look at what humanity built just to try and match this. Buried 100 meters underground across France and Switzerland, we built the Large Hadron Collider, a 27-kilometer ring of superconducting magnets. We strip hydrogen atoms down to bare protons and blast them around the track until they hit 99.9999991% the speed of light. That's over 11,000 laps around a 27-kilometer tunnel, every single second. When those proton beams smash head-on, they hit 4 trillion degrees Celsius. That's 250,000 times hotter than the core of the sun. They melt into quark-gluon plasma, a frictionless liquid expanding at near light speed. It's an incredible achievement. Except, compared to deep space, our multi-billion-dollar machine is an absolute child's toy. Out in the cosmos, nature operates particle accelerators that make CERN look like a grain of sand. Supermassive black holes at the centers of giant galaxies consume stars and ignite super engines called blazars. They blast relativistic jets of superheated plasma across thousands of light years. We aren't talking about tiny atoms here. We are talking about entire blobs of matter, carrying the mass of planet Jupiter, being launched at 99.99% the speed of light. The energy inside those jets could vaporize entire solar systems. And guess what? Those Jupiter-sized fireballs still aren't the fastest things in the universe. To find the real champion, we have to scale back down to a single subatomic particle and travel back to Utah, October 15, 1991. In the middle of the night, optical detectors at Dugway Proving Ground picked up a flash of ultraviolet light in the upper atmosphere. The data was so insane, scientists thought their equipment was broken. A single cosmic ray had slammed into Earth, traveling at 0.99999999999999999999999999999999999 times the speed of light. That is 23 nines behind the decimal point. If light and this particle started a race across 1.5 billion light-years of empty space, light would gain a lead of just 1.3 femtometers per second. After 1.5 billion years, light wins by 1 centimeter. Standing at the finish line, you couldn't tell who won with the naked eye. And because of Einstein's time dilation, to us on Earth, that particle's journey took 1.5 billion years. But to the particle, it felt like less than 48 hours. If you could ride that proton, you'd take a short weekend nap and arrive 1.5 billion light-years away. Scientists literally named it the "Oh my God" particle. A single subatomic particle, smaller than an atom, packed the kinetic punch of a baseball flying at 63 miles per hour. For 30 years, physicists hoped it was just a statistical fluke, a once-in-a-million anomaly. Until May 27, 2021. Utah again. A massive grid of 507 detectors picked up another monster, 240 exa-electron volts of energy. They named it the Amaterasu particle. It carried the impact of dropping a heavy construction brick on your foot from waist height, all packed inside one single particle. And here's where it gets terrifying. When scientists traced the Amaterasu particle back to where it came from, they found nothing. It pointed straight into the local void, a vast, pitch-black stretch of space with no galaxies, no stars, and no black holes. And according to the known laws of physics, the GZK limit, ultra-high energy particles cannot travel long distances across space without losing energy to cosmic background radiation. It had to come from somewhere nearby, which leaves us with two terrifying choices. Either there are invisible, ultra-powerful cosmic engines lurking in the dark voids of space, or our fundamental laws of physics are completely wrong. If you want to stay ahead of the curve and unlock the mind-bending secrets of the universe before everyone else, hit that follow button right now. Now tell me in the comments, do you think we've stumbled onto unknown physics beyond Einstein? Or is something massive hiding in that empty dark void? Let me know below.